So the next naming system that we're going to discuss is going to be the covalent naming system. And covalent naming systems are going to consist of all elements that are nonmetals. So they're all going to be nonmetals. And just a reminder, if we're looking at our periodic table and we have our staircase, our nonmetals are on the right-hand side. And so our nonmetals, they are always, when we're making a covalent compound, if you remember from Lewis dot structures, covalent compounds are going to share electrons. Okay, and since they're sharing electrons, so covalent compounds share. And so since they're going to be sharing electrons, they can share as many times as they want. So they can share in multiple ratios. So for example, we could have C sharing with oxygen once, or we can have carbon sharing with oxygen twice. So this would give us carbon monoxide, and this one would give us carbon dioxide. Very, very different. Carbon monoxide, if you breathe that in, you would die because our body can't process that. Carbon dioxide, not as dangerous. So it's going to create these different chemical properties for us. Ionic compounds always form in the same ratio. So ionic always are in the same ratio. And that's because they are transferring electrons. So for example, if we have magnesium, magnesium's always going to have 2 valence electrons it has to get rid of. And chlorine's always going to have 7, which means it's always going to take 1 electron. So whenever magnesium and chlorine form a compound, they are always going to form it in a 1:2 ratio. Because again, they are giving and taking. So they have a specific number they're giving and a specific number they can take. Okay, chlorine can only fit 1 more, so that's why we need 2 chlorines to take both of magnesium's electrons. Covalent compounds, again, they're sharing, so they can share multiple times. So when we go to name covalent compounds, because, for example, we can have carbon monoxide or carbon dioxide, depending on how many times they share, we need to represent what formula we are referencing in this equation. So we just went through this. So I'm going to go through the naming system and the rules, and then we'll kind of talk about the names. So these are going to be our prefixes. And again, because we're sharing electrons, we need a way to represent how many of each element we have in our compound. So we're going to use prefixes to represent how many are being shared. The rules that we are going to go through is the first element keeps its name, just like before. So again, all naming systems, the first element keeps its name. However, the first element we need to add prefixes. The only prefix we cannot add is going to be mono. So for example, if our first element we only have 1 of them, we do not put, like if we only had 1 carbon, we do not put monocarbon, we just put carbon. The first element can take any other prefix. So it can take di, tri, tetra, penta, hexa, hepta, octa. It just cannot take mono. The second element, we're going to also change the ending to IDE just like we have been for every single naming system. First element keeps its name, second element IDE, but again, we just have to include prefixes. This one, we're going to also add prefixes. And this can take any prefix. So we can take a prefix 1 through, and it goes higher than 10. We're just only going to worry up to 10. So the second element can have mono. The first element cannot have mono, but the first element can have di, just not mono. The last rule that we just need to be careful of is certain letter combinations. And you'll see it both ways. We're just going to follow the name that the way that is listed on chemical bottles. So if you have an A-O combination, meaning you have an A and an O next to each other, you are going to get rid of the A. If you have an O-O combination, you are going to get rid of one of the O's. And we'll go through what this means when we go through an example. So we already said CO is carbon monoxide and CO2 is carbon dioxide, but I want to go through how we got to that name using these rules. So we're going to look at our rules one by one. So the first element keeps its name. So we know that C is going to be carbon. All right, so that's the first rule. The next rule says we can add prefixes except for mono. So if we look, there is one carbon, and the prefix to one is mono, which means we do not put mono on we're not putting a prefix on carbon. Okay, the second element, we are going to change the ending to IDE. So we have oxygen. We already know that changes to oxide. But for the second element, we can add any prefix. So again, there is one, which means we're going to have mono again. So I'm going to write mono oxide. Okay, again, I saw up here one is mono, so I get mono oxide. We're going to look at our last rule right here where we say we cannot have an AO or an OO combination, and just check and make sure we don't have any of those. But if I look, I do have there an OO combination. So it's not going to be carbon monoxide. Instead, we are going to get rid of one of the O's, and it is going to become carbon monoxide. Okay, so again, that's where you see that OO combination. So the second element we're going to have is CO2. So again, the first element keeps its name, which we said is carbon. There's only one carbon, so we would get the prefix mono, but we said we do not use mono. The next element we have is oxygen. We change our ending to IDE. Okay, but now this time we have two. So I'm going to go up to my list, and I'm going to see 2. Okay, well, if I have 2 something, I'm going to write the prefix di. So it is going to be carbon di. I'm going to write my element oxide. So I'll have you guys try SO, and we're going to do S2F. Just want to do one where we do have a prefix for the first element. So the first element, again, keeps its name, which is just sulfur. However, you'll notice this time we have 2 sulfurs. So our first element can take any prefix except for mono. So since it says 2, that is the prefix di, which means we can use disulfur for this answer. Now we're going to do our second element. Again, we change the ending to IDE. So we're going to change fluorine to fluoride. But the second element can take any prefix. So we are going to look at how many F's we have. Okay, we have one F. That's mono. So I'm going to have disulfur monofluoride. So again, mono can be used in that second element. It's just that first element we cannot use mono. All right, and we can use any letter combination except for AO and OO. So you can have an II combination. That is okay. So that's okay, just not AO or OO. So why don't you, I'm going to have you guys also do these 2 on your own. Okay, so now we're going to go, and so now we'll practice going backwards. And backwards is actually a little easier because it gives you all the information you need and you're just copying it down. So here we have tetraphosphorus. All right, well, I know phosphorus is P. Tetra, I'm going to go up to my list. You guys are responsible to know this, but I'm going to look for tetra. All right, that's 4. So that's P4. Now I see decoxide. So I'm going to look at my prefix, dec, and then I know that oxide is oxygen. So I know it's oxygen. I look up here. Well, I see deca, not dec, but remember we cancel out that AO combination. So this was deca. And so we'd have P4O10. We're not crisscrossing. We're just literally writing the subscripts because it tells us in the name. Okay, number 2, it tells us we have bromine trioxide. So I'm going to write Br for bromine. Notice there's no prefix. That tells me that the first element must have had the prefix mono. But we don't put mono, so that's why it doesn't have one. So that means we just have one bromine. And then I have trioxide, so I know I have oxygen, and tri is 3, so it'd be BrO3. All right, so I'll have you guys try then 3, 4, and 5.